Okay, lesson 2 of the electricity module. And in this module topic, we're going to be looking at voltage and current in both series and parallel circuits. So first of all, a quick recap of what is a series circuit. So we'll start with simple with a cell going into, we'll have just a bulb and we'll have a second bulb. Okay, so series means one way around. Okay, so if the current was coming out of here, the plus side, there's only one way round. A bit like watching a TV series where if you miss one of the episodes, you kind of don't want to miss that. You want to go back, catch it so that the story makes sense. And same with series here. Everything has to go from one to another to another. Parallel on the other hand, so let's write it. So it's para, then it's double L because they're parallel to each other, EL. Parallel means more than one way round. So if we take those same two bulbs, this time we can show that they can go two ways round. We can have in red go number 1, they can go that way, or in purple they can go round that way. Okay, so number 2. So parallel circuits have 2 or more ways around. Highly technical term. Okay, now with that in mind, we're going to apply voltmeters and ammeters to look at how these circuits behave. So, a little recap. We'll do a table and we'll put the word name, and under that we'll have voltage and current. We need to do a recap just to remind ourselves what are the symbols, what are the units, what letters do we write, because it can get very confusing very quick. So if you don't want to write the word voltage, you can write the symbol capital V. If you don't want to write the word current, it is the letter I. The reason it's not C is that was already taken up to mean charge, coulombs, which we learn about in later topics. It couldn't have been Cu because that's already been taken for copper, cuprate by the chemists. So unfortunately it was an I. Next, what meter do we use? What meter? We use a voltmeter and an ammeter. Now I've left a little bit of a space between them, but it's not. It's all one word, ammeter. Okay, a voltmeter and an ammeter. Next, the symbols for those, so the symbols for an ammeter and a voltmeter are a V in a circle and an A in a circle, because the units are, let me just add those two lines, the units that we're going to be measuring in are volts in capital V and amps, capital A. So that's that. Next, about how we apply them. So I'm going to extend this out a little more. I'll write the words and then I'll show you it in action. So, application or adding. Let's put adding them. Adding the meters. Okay, so a voltmeter goes in parallel, whereas ammeter goes in series. So I'll draw a little diagram to show what I mean by that. I'm going to colour code them. Let's have that nice turquoise that I like and that nice purple. Okay, so let's draw a circuit. We call this a test circuit, and we're going to draw an ammeter in series. Ammeter. We'll get that purple just to show that that's that one there. Next, we have our light bulb. So draw our bulb. And then we complete the circuit like so. And the voltmeter goes around the thing you want to measure. So in this case, it's going to go around the light bulb like that. And that's my voltmeter there, and that is gone in parallel with the bulb. Now, one trick for remembering putting the voltmeter on, and that's Mr. Tickle. So I can't draw the Mr. Men, I can't even remember what they look like, but Mr. Tickle had big long arms, and he went around tickling people. And so when I think of the voltmeter, I think of him a bit like this. He goes around the thing he wants to measure. Want to measure the voltage of the bulb? Boop, around he goes. Want to measure the voltage of the battery? Boop, around he goes. Put something else in, around he goes. So I will always nickname him. The voltmeter is the Mr. Tickle of the metering world. With that in mind, let's have a look at now what kind of results we get. So we'll add a page. If I can remember how to, add a page. There we go. Okay, so let's first of all look at current, because it's easier. We're going to do a heading of current, and we're going to look at it in series, and then we're going to look at it in parallel. Okay, so series circuit looks like this. Let's put that there. Let's call that 10 amps. And we put a light bulb in, and we finish it off. If now we added another light bulb, so let's copy that, add that, but this time we're going to add an extra light bulb, like so. We see straight away that the current goes to a half. It goes down to 5 amps. So components means things like bulbs, motors, buzzers, anything you plug in. Components slow down current. That's our first finding. Okay, something else to pay attention to as well is if I put my ammeter this side, like that, I also get 5 amps because the flow of current does not change. So if I drew some charges like this, there they are. My charges, which is the flow of current, there they are. They just go down the wire, along, up, and they just keep going around and around. So the current remains the same wherever you measure them. So that's our final bit for series. The current is the same everywhere. Okay, now let's have a look at parallel circuit. So I'll just do a dotted line to show that we're separating them out. That was series, now parallel. Okay, we're going to do this again. We're going to put 10 amps. We're going to have one light bulb, like that. So with one light bulb, 10 amps. But look what happens when we add a second light bulb. When we add a second light bulb, that 10 amps actually goes to 20 amps. And that's because now there are 2 directions it can go round. And so more and more current can be drawn. What else do we see? Oh, let's write that up first. So this time, more components means more pathways, which equals more current. So more current can flow. It's a bit like adding a bypass road around the town. It means more traffic can flow around. So that was the first thing. Also, what happens if, and let's draw it again, nice and easy. Let's look at the numbers. So let's say 20 amps. We'll go to one light bulb and we'll have an ammeter there. And we'll have another ammeter and a bulb here. So we're going to peak how much current is going each way. And what we'd see is if these 2 bulbs were identical, so let's draw them in as light bulbs, then we should get 10 amps and 10 amps. And if we were to measure what was coming back out, we would get 20 amps coming back out like that. So in goes 20, 10, 10, back out comes 20. Okay, so we're seeing that current is shared out in parallel circuits. Double L E L circuits. Okay, so current is shared out in parallel circuits. And that's the first part done. That's current, all sorted out. Let's just highlight those. Okay, now let's look at voltage. So we're going to add a new page. Where am I? I'm here. Add a new page. Let's look at voltage. So before we talk about it, let's just say what is voltage. And it's the energy the charges carry. Okay, so we can think of them as the charges are like little delivery trucks. So the voltage is the amount they're carrying to deliver. So let's have a first look at series. We'll have, again, our circuit. We'll have one light bulb. We will put a voltmeter around it, the Mr. Tickle of the metering world. And if coming out of my cell was 6 volts of energy, then 6 volts goes there. So that's easy enough. But what about if we now added another bulb? So let's draw it again. You'll notice my drawings get less and less tidy as time goes by. Can't be bothered. Okay, so this time we've got 6 volts of energy, but this time 3 goes to here, which means 3 goes to here, assuming the bulbs are the same type of bulb. Okay, but that might not always be the case. We might have one bulb, like I've drawn here, a lot brighter than the other, so they don't have to be equal, but they do have to add up to the input voltage. So they've always got to add up. They add up to input voltage. Okay, so any numbers that you can add together to make 6 in this case would be valid. So what are we seeing? We're seeing that voltage is shared out. So that's our conclusion for that. Voltage is shared out. Now I'm going quite quick. You can pause it, rewind it at any point, but I'm just going to blast on three now to parallel. Okay, same thing. 1. Now I'm going to leave a big space so I can fit the other voltmeters in, like that. Let's have again 6 volts, and this time we have here 6 whole volts, and this one 6 whole volts. So what's going on? How have I managed to look like I'm conjuring up energy? Well, let's take a charge. Here's a charge. I will call him Barry. And he's going to get some energy. Okay, so there he is. He's got his energy. He's got 6 volts of potential difference. Now, he's flowing through the circuit, as charges do. And he gets here and he's got a choice. He can either go through the first bulb, drop off all the energy, then return empty, or he can go this way, drop off all the energy and go that way. So depending on the resistance of the cell, they will pretty much go 50-50. Half the current that way, half the current that way. And so all the voltage is dropped off. So he moves through. As he gets to this side, if I get the rubber just right, there you go. He then loses his energy because he's dropped it off, and he goes back round, picks up some more. So now he has his energy again. Oh, and I've left behind my energy. There we go. And he goes and he drops it off here. So there's no trick. The current has changed, which is kind of how this works. So let's get rid of Barry a minute. Bye, Barry. So here we see the voltage is the same for each. I'm just going to use the word component. Assuming the bulbs are equal. Another added bonus for parallel circuits, if one bulb breaks, let's just write it, if one bulb breaks, Doesn't matter. The circuit, the remaining, let's put it, the remaining bulb stays on. Okay, so if I wipe that bulb out, it breaks, doesn't matter. The other bulb will continue to stay lit up. Alright, it won't be any different. Another advantage is they are brighter in parallel. Brighter in parallel than series. Okay, and this is the reason why most lights now are rigged up in parallel. The lights in your house and Christmas lights. Now I'm going to shrink that and bring it all together now into a tidy little table, just to kind of cap it all off. Something easy to memorize. So let's put voltage, current, series, and parallel. We'll add our lines, turn it into a grid, come on. Straight line, boom. That way, and then that way, and that one. Okay, so in series we saw that it was shared out. Things like 10 volts equals 6 volts plus 4 volts, or 5 add 5, or 1 add 9. They don't have to be equal, but they do have to share it out. In parallel, though, it was the same. Okay, the 6 volts going in is 6 volts and 6 volts. Let's look at current. So, in series, current was the same everywhere. Current does not get used up. However, current in parallel was shared out. And again, you could have 10 amps going in, and that could go to 5 amps and 5 amps. However, it could also go to 1 amp and 9 amps. It doesn't matter as long as it adds up. Okay, so that's the thing to memorize, all put into one place. And I think that's the end of my lesson. A long one. Take care.